Redox is the contracted term for reduction oxidation. And we've got a very simplistic way of describing oxidation and reduction. This is what we'd say was our foundation tier definition. Oxidation is the gain of hydrogen, or it's the loss of oxygen. So if a compound gains hydrogen, we say it's been oxidized. If a compound loses hydrogen, we say it's been oxidized. Conversely, reduction is the loss of oxygen. So if a compound has oxygen in it and loses specifically oxygen, then we say it's been reduced. Or alternatively, we could say that if the compound gains hydrogen, then that's reduction. So a very simplistic term, and it's one that will fit some of the reactions that we look at, but not all. But what does redox mean in terms of oxidation reduction in terms of electrons? So oxidation is the loss of electrons. Oxidation is loss, oil. That's oil of oil rig. And reduction is the gain of electrons. So reduction is gain of electrons. That's the rig of oil rig. But how can you identify what's been oxidized and what's been reduced? It's by inspection. So we can either say it's lost or gained hydrogen, lost or gained oxygen. That might be a clue. Or where we can't say that specifically, we'll have to look at the electrons. But let's go for the simplistic stuff first. This is a nice way into deciding if something gains or loses electrons. Let's go back to one of the very first lessons that we had on making ions, and we came across the notion that all atoms wanted a full outer shell of electrons to be stable, and we know that sodium is in group 1, and sodium has 1 electron in its outside shell, which that means that shell isn't full. So to get a full shell, it either gains 7 electrons, which requires an awful lot of energy, or the easiest option is to lose 1. So all metals will lose electrons, and sodium is a metal. It'll lose 1 electron. So here you can see the electron in the outside shell. That's what it's going to lose in order to have a full shell of electrons. And so we form this sodium ion. And you can see there's the electron that it spit out. So the sodium atom has spat out an electron, which we can see there on the right hand side, and it's formed the sodium ion, which has a full complement of electrons in the outside shell. Because it's lost an electron, the electron's negatively charged, there it is on its own, it does mean that that sodium ion will be positively charged. Okay, so we've got conservation of charge, we've got 1 plus charge, which is the sodium, because it's lost the negative charge, which is the electron. So overall, we can see there we've got a balancing of charges. But how do we write that? Okay, we're not going to keep drawing these diagrams all the time. No, chemists like the shortcut, so we're going to use the symbol for sodium, Na. We're going to use the arrow that says it goes to or it forms. And it forms the sodium ion. So the plus, superscript plus tells us it's a sodium ion, and that's the plus sign, an electron. So you can see that the written line mirrors the diagram above. So we've got a sodium atom becoming a sodium ion and an electron. We can say in words, the sodium ion loses an electron. Loss of electrons is oxidation by our new method of definition. And because it's lost electrons and it's oxidation, we say the sodium atom has been oxidized. It's the sodium atom that's been oxidized, which tells us that the sodium atom has lost an electron. So now let's do a different one. Let's do a group 2 element. So magnesium is in group 2. And what can we say about magnesium? So pause the video or pause this talking now. have a look and in your head go through what is happening with the magnesium atom. So what you should have seen is that the magnesium atom has got 2 electrons in its outside shell. And so those 2 electrons it is going to lose. And it's going to lose them, and you can see in the diagram that we would make this magnesium ion. Okay, so we'll make the magnesium ion, and we've got the 2 electrons that the magnesium has spit out. And as you can see, the written form of that, so going away from the diagram, going to the written form, magnesium Mg, and that's the atom, will give us magnesium 2 plus ion. So that's a 2 plus ion. It's lost 2 electrons, so it becomes positive 2. And we've got 2 electrons that have been spat out, and there they are, plus 2 electrons with the negative charge on them. And you can see we've got a conservation of charge. We've got a 2 plus charge, and we've got 2 single minus charges. So 2 pluses and 2 minuses overall make 0 charge. So we've got 0 charge on the left-hand side because the magnesium's not charged, and we've got 0 charge on the right-hand side because the magnesium 2 plus and the 2 electrons, when we add them together, make 0 charge. So we've got a conservation of charge. How do we do this in writing? We say magnesium loses an electron. Well, in fact, it loses 2 electrons. And loss of electrons is oxidation. So magnesium has been oxidized. Okay, so the magnesium loses 2 electrons. It's been oxidized, and by the definition, loss of electrons is oxidation. Okay, so here we've got fluorine gaining electrons. So what happens to non-metals? So group 5, 6 and 7. Well, they will gain electrons. They're non-metals, they gain electrons. So here's our fluorine atom with 7 electrons in its outside shell. It's going to gain 1 electron. That comes from somewhere else. It comes from the other reactant it's going to react with. So it doesn't just happen to find an electron. It's part of the other half of the reaction. So there's the electron. It will capture that and it will put it in its outside shell. And there you can see the fluoride ion with the electron in its outside shell. So how do we write that? Chemists, being very lazy, will want to don't want to draw diagrams, will want to write it. So we will say the fluorine atom has gained plus an electron, has gained an electron to form, that's the arrow, the fluoride ion, F minus. So, in words, fluorine gains an electron. By definition, gain of electrons is reduction. So we can say that the fluorine has been reduced. The fluorine atom has been reduced. Okay, so can you have a go at this oxygen? So pause the video now and do this. Okay, so you should have said that the oxygen gains 2 electrons, and there are the 2 electrons that it gains, and that will give it a full outer shell, and it will form this oxide ion. So you can see the 2 electrons in the outside shell, and because it's gained 2 electrons, it's gained 2 negative charges, so overall that oxide ion is negatively charged by 2 minus. How do we write that? Chemistry shorthand, we'd say the oxygen atom has gained plus 2 electrons, 2 E minus, and it gives us O2 minus, so it forms O2 minus. And the words that go with that, oxygen has gained 2 electrons. By definition, gain of electrons is reduction, and so the oxygen has been reduced. Okay, have a go at this. This is an exam style question. All right, so using what we did in the previous slides, you've got, you need to be able to state which is being oxidized and which is reduced. Okay, so here's this exam question again, and I'll go through the answers. So the calcium loses 2 electrons. to become a 2+ ion. So there's, it's lost 2 electrons and it's become a 2+ ion. So there would be 2 marks. The oxygen gains those 2 electrons and becomes a 2- ion. So there's the 4 marks that we've got for that question. And then putting in the equations, the calcium, say Ca, the calcium atom, has become a Ca2+ plus 2E-, they're the 2 electrons, and that's oxidation. By definition, loss of electrons is oxidation. The calcium spit out 2 electrons. And we can see that the oxygen's picked up those 2 electrons. So the oxygen has gained 2 electrons to become O2-. That's the reduction part. Okay, mark yourself out of 4 for the words, and then you can give yourself 1 mark for a correct equation and 1 mark for saying whether it's oxidation or reduction. So again, that bottom part is worth 4. So in total, that whole question, 8 marks. Did you get all 8? If you didn't, make sure you use your green pen and add in the corrections. So here we've got a few more complex oxidation reductions. So have a look at each of these questions and decide if it is oxidation and if it is reduction. Okay, and they will get a little bit trickier as we go along, but if you spot how to do these can be very straightforward.